So we're going to keep working with undetermined coefficients. This time we want to look at how to handle the situation where your driving function g of x is actually a linear combination of many function families. So let's suppose that we were trying to solve this differential equation right here. So we notice that it's second order, it's linear, non-homogeneous, and it does have constant coefficients. So we know that the first step would be to solve the homogeneous equation and find y complement, and we're looking to find y equals y complement plus y particular. And so when we look at g of x right here, what we see is that g of x is combined from different function families. We have a third degree polynomial, we have a sine function, we have a polynomial times exponential base e. And so what we want to identify is that each of these would require a guess on their own. So for example, we could guess that y particular is going to equal, here we have a polynomial times exponential base e. It's a first degree polynomial, so we would guess ax squared, we would guess ax, a first degree polynomial, plus b times e to the x. For the sine of 3x, then we would need to guess plus, we need to add on to our guess. Sine of 3x requires abc times sine of 3x plus d times cosine of 3x. So we have that guess that we get from our cosine sine functions. And now I have a third degree polynomial here. So I'm going to go plus, now I need to guess abcd ex squared plus fx plus g. That's a second degree polynomial. I need to guess a third degree. So it'd be ex cubed plus fx squared plus gx plus h. So we have a third degree polynomial guess. We have a linear combination of the sine and cosine function as a guess. And we have a first degree polynomial times e to the x. So we have to deal with this linear combination of different function families, each of which is a legitimate undetermined coefficient function family. So we have to guess the combination of the different function families. And then what you can see is that this would be, it would be annoying to take the first and second derivatives of this entire mess. But fortunately, and I'll let you think about why this is true, it should be fairly easy to justify it. But fortunately what we can do is break this into multiple equations. So we can deal with each piece separately. So if we look at the differential equation, y double prime minus 5y prime plus 4y equals 8x e to the x. We could guess what I'm going to call y particular 1 for this equation. This is our polynomial times e to the x, so we would guess, and it's a first degree polynomial, so we could make a guess here, ax plus b times e to the x, and we could solve this differential equation for its particular solution. And then we could break it up and look at y double prime minus 5y prime plus 4y equals, and then we could just look at the case where we have it equal to sine of 3x. And then we would guess for this function, y particular 2 equals a sine 3x plus b cosine of 3x. And then we could solve this for y particular 2. We could solve this one for y particular 1. And then we could say, here's a third degree polynomial. Let's look at the differential equation, y double prime minus 5y prime plus 4y equals just minus x cubed. And then we would guess y particular 3 has the form ax cubed plus bx squared plus cx plus d, and solve this differential equation for y particular 3. So the idea is, as long as we keep the same differential equation here, the same homogeneous component, if we have more than one function family showing up on the right hand side as our g of x, our driving function, we can solve for each individual piece separately. And then for our overall function when we're done, y particular will be the sum of those individual pieces. So y particular will equal y particular 1 plus y particular 2 plus y particular 3. We just take the sum of the pieces. So this is nice because what it does is it allows us to deal with it in bytes instead of trying to take the derivative of the entire guess all at once. So that's how you deal with it when you have multiple function families showing up as your driving function. Just break it out into the individual families and then make the guess that we did when we made guesses for each of these three in videos 2, 3, 4. Go through the solution process for videos 2, 3, 4. Find the individual particular solutions and then do the linear combination of those solutions.